Hello, Math 141. Let's talk about money. If $2,500 is invested at an interest rate of 2.5% per year, compounded daily, find the value of the investment after A, 2 years, then 3 years, and then 6 years. Okay, so first of all, what is it that I know? I know that the uh, final amount or amount equals initial amount uh, times 1 plus I do have rate divided by n being how many times it's being compounded to the power of n times t. And notice that this is saying that interest rate of 2.5% per year compounded daily. And so the agreement is that every year has 365 days. I know we have a leap year every 4 years, but let's not worry about that. So mm, for 2 years, part A, I'm going to have A equals $2,500, 1 plus, the rate is 2.5%, 2.5 divided by 100, because remember, percent is a number divided by 100. So 0.025 divided by 365 to the power of 365 times 2. And I already put that in calculator. That's going to give me to the nearest penny, because we are talking about money, $2,628.17. So you are making a profit of um, $628.17 in 2 years. Now, let's say if you keep the same money for an additional year, 3 years, what happens to that? Uh, so I'm going to have for part B, um, amount equals 2,500, 0.025 over 365 times 3. And to the nearest penny, it's going to give me 2,694.70. So if you could keep it for 3 years, you would make more money, of course. And part C, let's say for 6 years. For 6 years, amount equals to 2,500. Then I have 0.025 divided by 365, which is my n, to the power of 365 times 6. And to the nearest penny, it's going to be 2,904.57. Okay. Now, some of you look at this and you say that, really, this is not very much money. And remember that in the beginning, that $2,500 is not, one of the numbers that it's not astronomical. Just think that if you had a business or somehow you could like uh, deposit $25 million, then it would make a big difference. Let me go to the next page and do another one. So this, in this problem, this is different. We are going to find the present value this time. So let me write down the problem. Find the present value. Find the present value of $100,000 if interest is paid, if interest is paid at a rate of 8% per year compounded monthly. Compounded monthly for 5 years. So let's look at the previous problem. You see, in the previous problem, we were looking for the amount, or you could call this amount also future value. So the future value of the money is what we found. Also the same thing on the page before for part A. Also, you see this amount right here is known as future value. However, in the problem that we are doing now, that $100,000 is our future value, and we are finding the present value. It's like this. Just pretend you want to purchase, let's say, a boat, a condo, something for $100,000 5 years from now. Okay. So this is like you want to find out that how much do you need to deposit in this account at 8% interest rate compounded monthly, so you will have a total of $100,000 in future. So let's say that P, which is my future value, equals P initial, or my present value, 1 plus R divided by N to the power of N times T. And once again, right now, what I have is the future value. So in future, I'm going to have I want $100,000. How much, okay, which is my present value, do I need to invest? So 1 plus. In this problem, notice that the rate is 8%, so 0.08. And it is compounded monthly, so N is 12 to the power of 12 times, of course, 5 years. Okay. And now I want to solve for P initial. So if I'm going to go ahead and divide both sides of this equation by the coefficient of P. So I can say P initial equals 100,000 divided by 1 plus 0.08 divided by 12. 15 times 12 is 60. And put that in the calculator. And let me start my calculator. So 100,000 divided by parenthesis 1 plus 0.08 divided by 12 to the power of 60. Enter. Okay, I have 67,121.04. So the present value for this account should be $67,121.04. I rounded it to the nearest pennies. Okay, if you need more help with problems like this, just shoot me an email and I will be happy to make videos for you. And I'll talk to you soon.